Yes, hello, grade 12s. This is Patrick Kamala. I want us to go through Newton's laws of motion and to see how we apply Newton's laws to answer the question 2 of last year 2021, so that we can make you ready for your test in term 1. You know, in term 1 you're going to have Newton's laws, and with them you're going to do actually momentum, impulse, and also define momentum and impulse using Newton's second law of motion. So today I want us to see how this question was supposed to be done before it comes in your test, you know. Okay, so now this question was done last year, November 2021. Let us see how it looked like. Okay, now before the question here, let me show the diagram. This is a diagram which you see here, a 20 kilogram block being pulled by force F, and a friction with the surface which has got friction and passes through points X and Y. This is 30 degrees here. Let us now see the actual question and see what it is saying. They said that a 20 kilogram block is placed on a rough surface inclined at 30 degrees to the horizontal. Okay, to the horizontal. Then a constant force F acting acting parallel to the surface is applied on what? On the block, so that the block moves up the incline at a constant velocity. Mark something here, constant what? Velocity. Constant velocity, okay. Then they say of 2 meters per second. They say refer to the diagram below. Then they say a constant kinetic frictional force of 18 newtons acts on the block. Okay, let us now see the diagram. This is our velocity here, which is 2 meters per second, and then this is our friction, which is 18 newtons acting on the block. What are the questions saying? Let us check now the question. They say this is our diagram here. They say state Newton's first law of motion in words. Okay, now that one you know already. We know that a body will continue in a state of rest, all uniform velocity, unless it is acted upon by what? By an unbalanced force. Okay, hope there we are together. So this is our body here, 20 kilogram block on an inclined surface which has got friction and at 30 degrees to the horizontal. Okay, next question says what? Don't forget the frictional force is they said, is it 18? Frictional force is 18. The velocity is 2 meters per second. That is constant velocity. So next here, what are we supposed to do? They said that draw a labeled free body diagram for the block. Now our block, it's on the surface, which means the surface exerts a normal force. Exerts what? A normal force pointing that way. And then, and because it has got a mass, so it has got weight. So the weight goes down like this. Okay, that's the weight there. And it's pulled by the force F. So that's the force F which pulls what? Which pulls this block. Okay, I think you can see that. And then it is opposed by friction. Okay, opposed by frictional force. That's our small f. Okay, so what you see in red here is going to be our free body diagram. Okay, let us label the free body diagram now. Now we said that this is going to be the what? The normal force. Okay, so this is the normal force, that is F normal force, and then this is the applied force F, which is pulling the body, taking it up the incline. Okay, this is the frictional force here, and because it's moving, we call it kinetic frictional force. That's why I call it Fk. And then this is the weight of the block, which we say Fg or mg or w. You can use whatever. You can use w, you can use Fg. Okay, so let me put here Fg, meaning the force of gravity. Okay, now after that, this is a dot in here. Okay, because they wanted a free body diagram. Hope we are together, guys. Let us proceed. If they give you 4 marks, it means there must be 4 errors which are well labeled. Now to continue, they said that calculate the magnitude of the force F. Okay, let's go back a little bit. Now this force which is pulling the block being opposed by frictional force and the Fg parallel, they want us to calculate it. And remember that the block is moving with a constant what? Velocity of how much? Of 2 meters per second. Of 2 meters per second, and the velocity is constant there. And the frictional force is 18 newtons. So they want us to get the force which is pulling the block at a constant velocity. So because it is moving, we bring in Newton's second law of motion, that is F net equals to ma. F net equals to ma, as you can see it is here. And now note something here, that the block is pulled up the incline, and that's by the force F net. So this force F which you see is the force which is pulling the body up the incline. Now the forces which are opposing this motion, we have got frictional force and also Fg parallel. Okay, we have what? We have frictional force and Fg parallel. That's why these forces must be subtracted. Okay, that's why we are subtracting them. That's why we are saying the force minus frictional force, again minus what? Minus Fg parallel equals to ma. Now our acceleration here is 0 because they said the velocity is constant, and we know that our acceleration is the same as change in velocity. Okay, that means v final minus what? Minus v initial. Ne? So if the velocity is the same, then it means that the v final and the v initial, they are the same. They are the same divided by change in time. They are the same. So if the v final is the same as v initial, it means the same as saying v final minus v final, which gives us 0 over change in time. So 0 over change in time, it gives us what? It gives us 0. And that's why I write here my 0. That's why I say mass times 0 here in here. Okay, so now the frictional force was given to me as 18. Now Fg parallel, it is the component of the weight which is parallel to the slope, ne? And given by mg sine theta, so equals 0. Now we are going to substitute. This one is 18 here. The mass was 20 kilograms, and then the gravity is 9,8, and then the theta of the incline was 30 degrees. Okay, so if I simplify this one here, guys, I get my force as 160 newtons. I hope we are together. But this one is minus, ne? So after crossing equal signs, they become positive, and when I simplify them, I get 160 newtons. Next question. They say now the force F is removed when the block reaches point X on the surface. The block continues to move up the surface and comes to rest momentarily at point Y. Assume that the kinetic frictional force acting on the block remains at 80 newtons as it moves from point X to point Y. Write down the net force acting on the block as it moves from X to Y. Okay, now don't forget that our diagram was like this one here. I'll try to show it here again. We had a force which was pulling this block, okay, and this force was being opposed by what? as being opposed by frictional force. Okay, so this side is frictional force here, and then now this is the body here. Now apart from this frictional force, there is also what we call as FG parallel, which is the component that is opposing the what? Also opposing the motion. Okay, so this is our FG parallel here. Now this was our F here, the force F pulling the block. Now the question says that the force F is removed. So when this F is removed, and we still have our forces, that is frictional force, and what? And the FG parallel. So the moment you remove the applied force, because of the initial momentum of the block, it's going to continue momentarily from the point they said from X to Y. Okay, so it continues momentarily from this point here up somewhere here, like they said, until it comes to rest. So this point X here, and then it travels up to point Y somewhere here. Okay, so don't forget that at first it was at constant velocity, and with constant velocity we got the answer for the force as 116, right? Now when we move the force F, the net force acting is going to be now in the opposite direction, but the same as the force which was pulling the what? The block. Let me say this again. I'm saying that the force is removed, and then now we are going to have a resultant down the slope, which is the same as the other force which we had in our previous calculation, this one here, which is 116 newtons. Okay, so it means our answer is going to be 116 newtons, but down slope. That will be our answer in that question. So here the net force is going to be what? 116 newtons, but downward, down slope. We've explained that. Now they say calculate the distance between points X and Y. Now to get our distance between points X and Y, actually we are going to have to use two equations. Don't forget that now the block is coming to rest from X to Y. So I'm going to use F net equals to MA, and then use VF squared equals to VI squared plus 2A tangent X. Now my F net equals to MA, I'm going to use it to get my acceleration, because now remember that at first my block was moving with constant velocity, and then all of a sudden the force was removed. So it means that now the velocity decreases from 2 to 0, so there must be acceleration. Okay, so if I use F net equals to MA, my net force is negative 116, the mass is still 20, acceleration is A, which I'm looking for in this case, so I divide by 20, which gives me negative 5,80 meters per second. So after getting this acceleration, now I come back and use the equations of motion, that is VF squared equals to what? Equals to VI squared plus 2A delta X, whereby my final velocity is 0, and my what? And my initial is 2. So this is 2 squared here. My acceleration is negative 5,8, then delta X, the same as that distance covered, which is XY in this case. So if I simplify this one here, this is 2 squared, which gives me 4. So the 4 becomes negative this side, and then if I multiply 2 times 5,8, I get negative 11,6. If I divide both sides by negative 11,6, I'm going to get my answer after dividing 0,34 meters. Okay, that's my distance XY, and I hope we are together. Now this method is what we use in grade 11. However, in grade 12 we have another method which simplifies this one here. That's method 2, and this method will be explained to you when you come to our extra classes. This is a solution here, and as we will go through it, I'm sure you will understand it. Okay, where we use the work energy theory, that is work energy equals to change in kinetic energy, and then we do the calculations as I will explain them when you come for the extra classes. Thank you so much for watching. You have an activity to do. Try this question out here, and then your answers, I need to see them. Okay, I need to see the answers when you are done with this activity. Bye bye. Catch you in my next video.